Hello everyone. In this video lecture we are going to study about dynamic memory allocation. As you know, C is a structured language and basically we use static memory. There are two types of basic memory, that is static memory and dynamic memory. Usually we use static memory. Whenever we initialize any variable or suppose array, at that time we use static memory. Static memory means what? Before the execution we initialize any variable with its size. That means memory is allocated previously, right? Already when I write the program and when I execute that program at a compile time, memory is already, total memory is allocated for that program, whether it is of a use or no use, right? While in a dynamic memory, the memory allocation is done at runtime. Runtime memory allocation is done in dynamic memory. Now there is some drawback of static memory, so that we are using this dynamic concept of dynamic memory. Now what are these drawbacks? So suppose, let us say I'm initializing an array. So I'm having an array integer a of size 10, right? So this means whenever I'm writing this and compiling my program, at that time an array a contiguous memory, that means suppose I'm starting with 1011, so 1011, 1012 up to 1020, right? That contiguous memory is allocated for this array, right? Now it might be possible that during the program I use only 3, right? I'm storing only 3 value in this array during my program. So that means what? 7 locations are still empty, right? The 7 locations are still empty. Out of 10 I have used only 3, right? While 7 are empty. So that is waste of memory. Now if you say that instead of 10 I initialize with 3 only, right? You can do that. But each and every time of the execution you are not aware about that whether you are going to use 3 data, 4 data, 5 data, right? It might be possible that if I am having a 10 data and at the time of execution I need 13 data. So 10 data is already stored in this array. Now what about the rest 3? For that again I need to change the size of the array, because I cannot store this in the same array, right? So I have to store this. There is an overflow, right? So for this overflow I need to again resize my array, right? So if there is no possibility that at the runtime I can resize my array, right, in static memory, because again I have to make a change in my code, right? I have to change this size from 10 to 13, then and only then, and second time when I execute, then and only then I will be able to add 13 data, right? So that is the drawback of static memory, that previously we are not aware about that how much memory we need, right? So instead of this, what we are going for the dynamic memory. So what is dynamic memory? In dynamic memory, memory allocation is done at the runtime, right? Whenever you execute a program, right, when you run the program, at that time according to your need it will allocate the memory, right? So there is no waste of memory, right? Wastage is not there. and it might be possible that you need more memory, so that is also possible, right? So that's why we use this dynamic memory, and it is an important topic for memory allocation. Now there are basically three types of memory allocation, that is malloc, calloc and realloc. So first we see the malloc. Malloc means memory allocation. Malloc stands for memory allocation. It allocates a single large block of a memory with the specified size. This size should be defined by us, right? So it will allocate a single large block of memory with the specified size. And it will return a pointer. What it will return? It will return a location. Location, that means address, right? An address, usually we store address in a pointer, right? So it returns a pointer of a type void. There is no type because it's an address, right? So the pointer is of having no type, so we need to typecast it, right? So which can be cast into a pointer of any form, right? So it will return a blank, right? And then we need to typecast that, right? So here we are having the syntax, that is PTR. PTR is just a variable. I can take any other variable A, B, C, D, right? But it will return a pointer that therefore your convenience I am writing over here, that is PTR, right? Why? Because it is returning a pointer, right? Here I need to write malloc. Before that malloc I need to typecast it, right? So cast type and a star. The star is compulsory. And here I need to write byte size, right? Size of my memory, right, which I needed, that I have to mention over here. So just we'll take one example. That example, PTR is equal to integer star, right? Why here integer? Because I need the pointer and I want to store it in an integer form, so I need a pointer of integer. That's why I have written integer star malloc. Now here what I have written, instead of this I can write directly 40, right? Or I can say 400. So it will return a 400 byte of size, right? But here what I am doing, I don't know right now that what is the size of integer, right? Usually we know that it's a 4 byte and 2 byte, right? In the previous system it was 2 bytes, and in a newly system it is 4 bytes, right? Integer is having 4 bytes, right? But if you don't know, that's why I'm using size of. Size of is a function. So whatever you write in a size of, it will return the size of that particular thing. So size of integer, it will return the size of integer, that is 4, right? If I write size of character, size of float, it will return same as, right? Now what I am doing, size of integer, that means it will return 4. But what I need the size 400, right? So I am multiplying this with 100, right? That means this pointer will return, it will return a block of memory, right, of the size 400 byte, and the starting address that is given to this PT. Getting this, right? So let us take one example. So if we go for the example, first here I am having header files hash include stdio.h. Here I am adding one more file, that is hash include stdlib.h, right? If you want to use dynamic memory allocation, you need to include this library. This is important, that is hash include stdlib.h. Now I am having void main. Here I am initializing a variable. In that variable 2 is my normal variable, that is n and I, right? Here PTR, that is my pointer, so I need to initialize it with a star. So star PTR, that is my pointer, right? Now I'm assigning a value, that is n is equal to 5. Now after this, what I am doing, I am allocating a memory using malloc, right? So integer star, and I need that of an integer only, because here my pointer is of integer type. I need to store the data of integer, right? So here I am having typecasting, that is integer star, then malloc. Then what I need, that size of integer, but how many data I want to store, that is 5 data I want to store, right? So that is in my n. So n into size of integer, right? This is static because I have already done n is equal to 5. But if I take a value from the user and store it in a n, so I can directly do that n into size of integer, right? Here I am assigning a value directly, but instead of this you can do that printf enter n, and I am storing it scanf %d ampersand n, right? So you can replace this statement with this two statements, right? This is a value taken by the user, this is a direct value I am assigning 5, right? So whatever value here that is stored, that would be given to this n, and n into size of integer, that is multiplied with 4, and that value is assigned, that much block is assigned, right, to our program, and that first location is given to the pointer. Now it might be possible sometimes it doesn't go in such a manner that memory allocation is done. It might be possible some errors are there, right? So if this code won't work at that time, this PTR will become null, right? So for that we are checking this. If PTR is equal to null, if my pointer is equal to null, then printf memory not allocated, right? I'm just printing a message that memory not allocated, and I'm returning from this, so it will terminate your program, right? It will just print this much and it will terminate the program, right? If it is not like that, then it will go for printf enter elements, right? That means it's just a message for user to say that enter your elements, right? Now what I'm doing here, I'm applying a loop, that is I is equal to 0, I less than n, I plus plus, right? Now I'm scanning the data %d and storing at ptr plus I. Here I'm not using array. If you want to use that array, then also you can do that, but right now I'm not using array. I'm directly storing it at a particular location, right? Now here I have not written ampersand. Why? Because if I'm having a normal variable a, so I need to write ampersand a, but ptr itself a address, right? A is a normal variable, so a is not an address, so I have to write ampersand a. But ptr itself a address, so I cannot write ampersand in front of address, right? So it is already address. Now what I am doing, I am doing ptr plus I in my loop. So first time I is equal to 0. So ptr plus 0, that means for example ptr is 1024, that is some location. So 1024 plus 0, that is at that particular location only my data is stored, right? Along with this, in this loop only I am printing the data. That's why I have written star. Star means what? Value of that, right? Printf %d star ptr plus I, right? If you want, you can print it in another, you can take another for loop and you can print that, right? Now again my I will be incremented, because this is for loop, right? I will be incremented with the 1, right? And this is ptr plus 1, right? And it is a pointer, so it will go to the next memory location, right? Next memory location, and it will store the data here, there, right? In such a way it will done up to 5. 5 means 0 1 2 3 4, 5 times, right? I is equal to 5, that is terminated, right? That is not true, that's why it is terminated, right? But for 0 1 2 3 4, for the 5 data it will store and it will print, right? Now here one more important thing, that I am done free ptr. Free ptr, why I need to do this? Free is another command of dynamic memory allocation. Your memory is allocated dynamically, but it is not freed automatically, right? if you close your program, then also it will not free up the memory. So what you need to do at the end of the program, again you need to free that memory, right? So free, in a bracket you need to write the variable name whatever you are having over here, right? So I need to write free ptr, so it will free up that space that is occupied by us in this program, and then get ch, right? So this is the example of malloc. Next we are having calloc. Calloc we'll see in the next video lecture. So I hope you understand this malloc method of dynamic memory allocation. In the next video lecture we'll gonna see the realloc and calloc. Thank you very much.